do the task, from the start. The first box, complete the sentence, choose the answer from the box. Potential difference tells us how hard a battery pushes around the circuit. Pushes what? That's not correct. Think about it again. We already have the concept of current. Pushes. Is there any other words in the given box which is more appropriate than the word current? What is current? Current is the flow of
cái flow of electric charge.
Exactly. And what are the electric charges in the given box, the words in the box? No. Push is the charge, yes, or electrons. Depends on if we have other words in the below statements that we use other words like electrons. Okay, the next thing, potential difference is measured in voltage. No, it's measured in means the unit of that quantity. So that is not the word voltage, another the word. Measure in, for example, current is exactly. Current is measured in amperes. Resistance is measured in ohms, and potential difference is measured in volts. Using voltmeter, correct? And the next thing, connected in. Do you know how we connect a voltmeter into a circuit? It is given in the below diagram. This is the diagram. How we use a voltmeter. So no, it's not in series. You see, the two ends of the voltmeter is here, letter V. The two ends of the voltmeter is connected onto the two ends of the light bulb. And this connection is like connecting the two light bulbs, you see? So what's the name of this connection? It is not in series, so that is exactly easy. Remember, the voltmeter must always be connected in parallel with the device that we want to measure the voltage applied to it. The next time I will give you some other examples and exercise relating to constructing the electric circuit using the FET. Okay, the current, the flow of electrons, okay, around a circuit. It is more correct if we say that is the charge, but we already used the word charge on the upper paragraph here. The higher the current, the faster electrons move. Yeah, so that is definitely the word electrons. Current is measured in amperes. Yeah, in amps for short. Using ammeter, correct. Connected, and similarly, yes, we are given a diagram for the connection of the ammeter in the circuit, which is in series. Okay. The next activity here, tick the correct box to show if each statement is true or false. You can do that, right? I think it is easy for you. All metals are magnetic. Can you explain why the first sentence is not true?
Tại vì không phải Không phải metals nào, không phải metals nào mà cũng magnetic.
Can you give example of a
Uh,
non-magnetic material, metal, and in English, please?
Aluminium.
Aluminum, yes, exactly. Any
Yeah,
other metal
copper.
which is not magnetic?
Copper.
Exactly, very good.
Okay.
Yeah. All magnets have the North Pole and South Pole.
Cái từ đó nói là all metals chứ.
Yeah. Yes, magnets always have North and South Pole. Okay. There's no magnets with only one pole. What happened to a magnet, like a bar magnet that we normally see in school or at home? Probably we accidentally have it. What happened to it if we break that magnet into two parts, two pieces?
Thì nó sẽ thành hai cái magnet mới.
Exactly, very good. Circle 3 magnetic metals in the list below. And there's one interesting metal, which is gold. Gold is magnetic or not? Have you ever touched gold?
Rồi.
Yeah, we normally use gold as jewelry, huh? Like a bracelet on your wrist, for example.
Đã từng đụng rồi. Trong bảo tàng.
Museum. Okay. So please circle 3 magnetic material. Yes, that cobalt. 3 things, 3 metals. Cobalt, iron, nickel, very good. Those are 3 most common and strongest magnetic materials that can be easily magnetized. Next time we will look back into the document we studied last time about 3 different types of magnetic materials. Do you remember? Like ferromagnetism, paramagnetism. Yeah, we look back into that later.
Yeah.
Tick the correct box to show if each statement is true. An atom has equal number of protons and electrons. Is that correct? Yeah, it can be considered correct because it is not mentioned that is a normal neutral atom or an ionized atom. So we assume that it is a neutral atom and the number of protons and electrons are equal. That's true. An atom has overall positive charge. False. Well done. Neutrons are negatively charged. Neutron negatively charged. That is not correct actually. Neutron, the word "new" stands for neutral. Neutron has no charge. Okay, it's neutral. So the answer is false. Protons has positive charge, electrons negative charge, and neutron is neutral, no charge. If a material gains electrons, it becomes positively charged. That's false. So what is the right answer for the last box? Material gains electrons, it becomes what? It is false. It is not. It will not become positively charged. So what will it become?
Negatively charged.
Yes, exactly. Explain why a person's hair stands on if they touch the dome of a Van de Graaff generator. Do you know that Van de Graaff generator? Con có biết cái máy đó không? Have you seen the picture of the Van der Graaf, the hair standing up?
Có phải cái hình tròn đó không?
Yeah. Let me search
Có
the
phải
picture
là
and put
ngón
into
tay
that
mình cái hình tròn
graph.
đó không?
Yeah. Here. Looking for picture and I will copy the picture into the board so that you can see the Van der Graaf generator again. Here it is. That is a machine that generates the charge. The electrons are stored on that half spherical sphere, okay, at the top. So can you explain why the hair of a person, or in this case the girl, stands up? Firstly, just answer, can you do that? If you can, I'll help. But I like you, or you can use Google, search for the answer. Why hair stand up when touching a generator, Van der Graaf generator? You can use a Google. Okay, the positive charge repel each other. How do you know that they are the positive charge? It could possibly the negative charge. Repel each other, but where are they? Where are the charges? The charged particles? Where do they stay? And how do they, relate to the hair? The charged particle on the generator will move to her body, the person's body, okay? And there's a secret in this experiment. The person must stand on an insulating chair, like a wooden chair or a rubber plastic chair, to isolate herself from the ground, okay? Because if she stand barely on her foot on the ground, the charge will go from the generator through her body to the ground, causing a great current that can hurt her body, okay? So she must stand on a wooden chair before touching the generator, okay? The charge will move from the generator to her body and her hair, and because they are the same type, could be positive, could be negative, but most of the case they are negative, not positive, because the electrons are generated by the rubbing, the friction between the two materials, and then store on the sphere, okay? Those electrons will move to her hair and repel each other because they're the same type. So you don't need the word positive, you can ignore that, just say the charge, or you can say negative charges, okay? On her body, yeah. They move from the generator to her body and her hair and then repel each other. So please change the explanation, making it clearer. Mentioning that the charge move from the generator to her body. Con làm cho cái câu trả lời nó rõ hơn nhé. Cái charge nó phải di chuyển tới cơ thể của cô ấy trước, sau đó thì nó mới đợi nhau. Okay, I'll type a simple sentence, okay? The charge on the generator moved to her body and repel each other. That is the simplest way of explaining this. Okay. Move the charges and repel each other, making her hair stand on. Okay. So now please do the next activity, choosing the answer from the box. Label the diagram, choose the answer from the box. The particle and the small red particles around, orbiting in circles around the nucleus, they are called yes, electrons orbiting around the nucleus. The nucleus consists of protons and electrons. Protons are positive charged and neutrons are negative charged. Well done. Match the name of each subatomic particle to its charge. And the charge are given in the number 1, 0, -1, which are actually 1 stands for one elementary charge, which is the charge of electrons is extremely small. It's called elementary charge, which is 1.6 times 10 to the power of -19. Do you know that? You have already studied the negative power, right?
Đã từng rồi.
Yeah. And the charge of electron E is that small, 1.6 times 10 to the power of -19, and it is characterized by, it is actually negative charge. I put a negative sign here, and that is written as short by -1. 1 for 1 E minus 1.6 times 10 to the -19. Okay, so please connect, use the pen to connect the subatomic particle to its charge. That's simple activity, huh? Một con này dễ mà con làm được chứ, sao mình hơi chần chừ vậy? Electron, what is its charge? It is here. Okay. Yeah, and proton. Proton is a positive charge.
Neutron là 0.
Yeah. Okay. The next exercise, complete the sensei, choose from the box. Very easy, huh? This is about electromagnet, which we studied a few weeks ago. But we're reviewing all the things that we've studied about electricity and magnetism. Okay, the string of electromagnet can be changed by changing the number of. That's the correct answer. Very good. It's just a little bit too long for the given bracket, huh? Length. Changing the number of coils. Yes. The greater number of the coil, the weaker the electromagnet. When you're doing that, I will put more exercise on this board.
Dạ.
Okay.
Đây. À.
The greater the number of coils, the weaker the electromagnet. No, it's the stronger, not the weaker. More coils will make the magnet stronger. Mình gia tăng số vòng dây, nó sẽ làm cho cái magnet nó stronger nha con, không phải weaker. The electromagnet, the stronger the magnet, the less paperclip. No, the more, not the less. Yeah.
Cái không có đạo phân tử tức là brass coil, đọc được.
Okay, the next activity, use the keyword to explain what the diagram below shows, that is electromagnets exactly. Identify the variables in the electromagnet investigation. Independent investigation. We want to figure out what can make the strength of the electromagnet stronger. Okay. Electromagnet investigations. So we will measure the magnetic field, the current, and the number of the coil, increasing the number of the coil, remaining the battery. For example, we remain the battery, so the voltage of the battery is the control variable. Voltage remain using only one battery. Okay, we don't need to change the battery, but as we already studied, increasing the voltage will definitely make the electromagnet stronger. Okay, but in this investigation we want to investigate how the number of the coil will increase the strength of the magnet. So the dependent variable is the magnetic field strength. Magnetic field strength. This is a new word that you should notice. Okay, and remember the strength of the magnetic field strength. And independent variable is the number of coil or the current. Actually, the current results from the voltage and the number of coil, because more coils, conducting coil also have a certain resistance, and increasing the number of coils will increase the resistance and therefore could result in a smaller current if we use the same battery. Okay, so the better way to make the electromagnet stronger is to use a higher voltage. Okay, so we can keep the voltage the same and change the number of coil. In that case, the voltage is control variable, number of coil is independent variable. Okay, or we can do it oppositely, maintain the number of the coil, control variable. Okay, and change the voltage and see how the voltage affect the strength of the electromagnet. So both way are both correct. Okay. Number of coil and voltage. So that is how we do this problem. Identify variables in the electromagnet investigations. Now please do the next one. Complete the table, the length, the potential difference, the current, the resistance. Use the equation, Ohm's law equation, okay, to calculate the resistance. Please type the number of resistance, the value of resistance here on the table.
Okay.
Potential difference in current. Ohm's law say that the voltage equals the current times the resistance. Yeah, and therefore we can have a similar equation, which is resistance equals voltage divided by current. Okay, so yeah, 300. Wait, that's not 300 because 10 divided by 5 divide not multiply, còn nhân vào là đúng không? Nhân vào là không đúng. Phải chia nhé.
tập 1
10 divided by 5, that gives 2, obviously.
That gives 2, hai cái, hay hai. Đây.
And the other, the second row is not 2, it's 10 divided by 2, which is 5, yeah, ohms. That is the resistance, how we calculate that. Easy, huh? And the last row describe how the length of the wire affects its resistance according to the above table. What do you see when increasing the length from 30 centimeter to 60? The current decreases, the resistance increases, right?
Yep.
So how do you answer the last question? How the length of the wire affects its resistance? We can see directly from the two values that we have just calculated, 2 and 5. So when increasing the length, the resistance will
increase.
Exactly, yes, increase. Yeah, the more resistance. Let me make it a little bit smaller to fix in this area. Okay, the more resistant, the higher, the greater the resistance. Okay, we should use the word greater rather than more. Okay, that is, you know, physically, scientifically more correct. Choosing the word. Okay, it will be the Y will be. Okay, so let's move on to the page 3. You're doing very well. That is so good for today's lesson. Are you on page 3 already? Yeah, let's do that. Student makes a circuit in the figures and wants to measure the current and potential difference in the circuit. Draw a component on the figure that would allow the student to measure the potential difference across the bulb. What do we use to measure the current, the voltage? A voltmeter. Yeah. And how do we connect that into the light bulb?
Thì mình phải connect nó vào cái circuit thôi.
So how do you connect that? Use the pen tool and draw on the diagram, the figure. Yes, very good. But should be a little bit more beautiful with the voltmeter, huh? Do it again, it's quick, huh? A circle and measure potential. The first question is just the potential difference, which means the voltage. So you haven't needed a ammeter. We don't need an ammeter yet. Okay, please draw again the voltmeter, make it a little bit more beautiful. We have the line here. Yes, that is the the circle. Too ugly, huh? Okay. Anyway, okay, this is voltmeter. make it a little bit smaller, also smaller, put it in the middle, and then we connect them in parallel like this. Okay. The question 2 here, write down the equation that links current, potential difference, and resistance. That is a theoretical question that we've done many times, huh? Ohm's law, but write in the terms equation, not the word. Okay, and that equation is I equals what?
I equals
V.
Times.
No, not time.
Resistance. V chia cho resistance hả?
Yes, divided by resistance, and we use the slash like this, indicating the division. Okay, or we can write I equal V over R. I equal V over R. Okay, so please write in. You can type in I equal V over R. Okay. The current is proportional to the voltage and inversely proportional to the resistance. The resistance is at the bottom of the ratio. So we say that the current is inversely proportional to the resistance. Ủa, con viết chưa sao mà mãi nó không hiện ra nhỉ? I equal, okay, V over R. It replaced the word resistance by just capital R. Capital R stands for resistance. Con thay thế nguyên cái từ resistance bằng một cái chữ capital R thôi. Tại vì cái đề bài người ta nói rằng là mình viết equation, mình không cần viết toàn bộ cái từ ngữ ha. If they do not ask for writing the equation but states the relationship between current, potential difference, and resistance, or state the Ohm's law, then we will say that the current is proportional to the voltage and inversely proportional to the resistance. But in this case, you just need to write the equation V over R equal current I. Okay? Mình dùng chữ R thôi, không cần dùng viết toàn bộ chữ là resistance. Okay? Question number 3. The current is 6 ampere in the circuit above, 6 ampere. The potential difference across the bulb is 12 volt. What is the resistance? Hello, Tú ơi, sao hơi chậm thế?
Thì đó bị lát đâu có chuyện ký con cười.
How do we calculate resistance? Using the above equation, right?
Yep.
And we've done it in the table on page 2 recently. Just done that.
Hi.
Wait. How did you calculate the resistance to be 12?
12 chia cho 6.
Okay.
Lấy đầu tiên là mình lấy.
Okay, so please type in 12 over 6 equal 2 and add the unit into the final result. The unit is ohm, not 6, okay? What do you mean by 12 here, unit 6? What are you doing? That is totally wrong. Okay? 12 right on here.
12 divided by 6.
Yeah. Divided by 6 equals 2 and ohms. Con hãy viết vào toàn bộ cái equation cách tính đầy đủ ở trong này nhé. 12 over 6 equal 2, and I already written the unit for resistance for you, which is ohm. Con gõ thêm vào đi. 12 chia cho 6 bằng 2. 12 over 6 is 2. No. You type here. The answer here, the resistance is 2. And the unit is ohm. No. Resistance is 2. The unit is ohm. 2 ohm. Use the pen. No. The unit is not 6. Oh my god, the unit is ohm. Okay, resistance is 2, and here you write the calculation 12 divided by 6 equals 2. Okay, this is the whole work showing how we calculate the resistance. Okay, and then put the unit behind the result. Okay, and this is the summary of the answer. Okay, the next question 4 suggests how the brightness of the bulb could be increased.
That's how the brightness of the bulb could be increased.
Please write a sentence summarizing how we can increase the brightness of the bulb. Question 4 here, you can write on top or at the bottom. Add more cell, exactly. Or we can say increasing the voltage. Okay. Shorten the wire. Shorten the wire, yes, will help. Yes. Yes, exactly. Yes. That is correct. The answer is okay. But shortening the wire is not a very good solution because it will not change the resistance very much. It changes a little. It will decrease the resistance when shortening the wire, but not much. Okay. Adding more cell is more effective. Okay. Adding more cell, or you can write increasing the voltage. Increasing the voltage. Shortening the wire, you can say reducing the resistance. Okay. The next question on the left, on the right here. Name two types of the circuit in the figure. Very easy, huh?
Types of circuits. Theories.
Circuit A is series, exactly, very good, and circuit B is parallel. Now, question 2, name the component that is used to measure the current, which is here. When adding the text, chỗ mà add text này con có thể chọn cái size chuẩn này trở thành size normal ha. Yeah, normal is chuẩn, right? Okay. Name the component used to measure the current. What do we use to measure the current? We have studied many times. That is the ammeter. What are you doing too? Mình chưa tới hết giờ đã mệt rồi hả? Where are you? Alo. Yeah, ammeter. Question 3. Compare the circuit and potential difference across the bulb. Okay, okay.
Nó bảo á, nãy nó báo là tác của bên nó bị hư đó. Thì không biết gì nữa.
Okay. Compare the circuit and potential difference across the bulbs in two circuits. In which circuit the potential difference, meaning the voltage applied to each bulb, is greater than the other? Trong cái circuit nào, parallel hay là series, thì cái bóng đèn nó sẽ sáng hơn. The bulb will be brighter, and meaning the voltage applied to that bulb is greater than in the other circuit. Trong hai cái mạch điện circuit này thì bóng đèn ở mạch nào cái circuit nào nó sẽ sáng hơn. You can use the FET simulation, connect the bulbs, the battery in two ways like that, and check. Okay. After checking that, I'll help you to explain why. Do you remember which circuit the bulbs will be brighter?
Cái circuit ý là compare hai cái circuit này hả?
Yes, yes.
Cả hai cái đều sáng bằng nhau.
No, it's not correct. Use the FET, open the FET simulation, and do, construct the two circuit. Con hãy làm cái này trên FET ha, và thầy sẽ gửi cái link electric và con share screen cho thầy xem nhé. Circuit construction. Share your screen so that I can see what you're doing. Okay, here the link. That is kind of slow today, huh? Because the internet, we have the cable break again.
Share. Ủa, nó tự làm sao?
Click on construction kit. Construction electric. Yeah, exactly. The internet today is very slow. Yes, very slow.
Năng không có load. Thử vậy. Để kênh load xong, để kênh load hết mọi thứ xong kênh share screen luôn nha.
Okay.
Thì nó sắp load xong rồi. Ok, load xong rồi cuối cùng. Yeah, share screen.
Okay, good job, con.
Cuối cùng.
Okay, so please, save the space so that you can construct two circuits on the same page, on the same screen. Okay, one circuit is a series circuit on the left, and the other is parallel circuit, including the same battery, two light bulbs for each circuit, and an ammeter for each light bulb. Con định connect hai cái battery series với nhau hả? Yeah, we can do that. You can use two battery connected into series, or you can only use just one battery. That is enough. It is okay to use two. Okay. So we see the current is 0.9 ampere for the two light bulbs. Okay, the next circuit is a parallel circuit, with the two light bulbs. And put an ammeter into it. Yeah, very good. So that tiết kiệm thời gian, mình không dùng nhiều sợi dây ha. Okay. Another light bulb. Okay. Yeah. Okay. So what do you see? Which circuit has a higher current and brighter light bulbs?
Cái parallel circuit.
Yeah. So that's very good that you've constructed the two diagrams. Now return to the Jamboard, and you can turn off sharing the screen now and answer the questions. Compare the current, the potential difference across the bulbs. In which circuit the current is greater across the bulb? The parallel circuit, as you have seen in the simulation fed.
Parallel circuit has more.
Yeah, has higher current. The current in the parallel circuit is higher. The current passing through each light bulb in the parallel circuit is higher, greater. Yeah, and how about the voltage? You can return to the circuit that you constructed in FET and use the voltmeter to measure the voltage. Or you can recall the thing that we've studied, that in the parallel circuit, the voltage of each light bulb will be exactly equal to the voltage of the batteries. Okay, so I can write V1 for the voltage for the battery up here, will be equal to V2 and equal to the total V of the battery, okay, for the parallel circuit. But for the series circuit, the voltage of each light bulb is half of the voltage of the batteries, and the sum of the voltages of the two light bulbs will be equal to the voltage of the battery. Okay. Con có thể dùng cái voltmeter để mình measure, và nhớ là mình đặt hai cái đầu dò của voltmeter màu đỏ và đen đấy ha, và đúng cái vị trí. So please complete answering this question, comparing the potential difference, and then we can stop for today's lesson. That's quite effective lessons. So please answering the comparison about the voltage. The voltage across each bulb in the parallel circuit is higher than that applied to each bulb in the series circuit. Con share screen lại đi cho thầy xem nha, cái screen fed ấy. Con share cái screen lại đi. Mình sẽ dùng cái voltmeter để mình measure cái voltage của mỗi một bóng đèn ha. We use the voltmeter and measure the voltage of each light bulb. Okay. Okay. No. Wait. Put the voltmeter between the two terminals, each light bulb, one light bulb only on the parallel circuit. Con đặt giữa hai đầu, một bóng đèn thôi, không phải hai bóng đèn. The red needle is in between the two light bulbs. Con đặt cái đầu màu đỏ ở giữa hai cái bóng đèn. Move the red needle. Okay, that is 9 volt. Okay, and the red needle is on one side because the question is the voltage applied to one bulb, only one bulb. So you can see that the voltage applied to each bulb in the parallel circuit is 9 volt. Okay, and when you compare to the parallel circuit, that is 18 volts, right? And remember, last time we studied the parallel circuit, the voltage of the parallel components will be exactly equal to each other and equal to the voltage of the battery, which is 19 volts in this case. Okay, so, and if you do that similarly, measuring the voltage for each light bulb, one single light bulb only in the series circuit, you see that each light bulb has the voltage of 9 volt, which is exactly half of the voltage of the batteries. Okay, con dùng hai cái battery, tổng cái voltage là 18 ha, và con dùng hai cái bóng đèn giống hệt nhau, identical light bulbs, cho nên là mỗi bóng đèn connect series với nhau nó sẽ có một nửa cái voltage. They will gain half the voltage of the battery, which is 9 volts. Okay, so the answer, please complete the answer, and we can done the lesson today. The voltage applied to each bulb in the parallel circuit is greater than that in the series circuit. Lưu ý rằng nó là voltage của mỗi một cái light bulb thôi nha, không phải là total voltage. And we will keep practicing this topic next time. Con quay lại với cái example đi ha, mình complete cái answer cuối cùng. Now, please write the final conclusion. The voltage applied to each bulb in the parallel circuit is greater than that in the series circuit. The voltage applied to each bulb in the voltage applied to each bulb in the parallel circuit is greater than that in the series circuit. Of each bulb, not both bulb nhé. Mình xây cái từ both này thành từ each. The voltage of each bulb in the parallel circuit. Tại sao thầy đọc một đằng mà con viết ra một nẻo vậy? Nó không giống với thầy đọc gì hết rồi. nó phải né, nó phải similar chứ.
Thì đó là both theo kiểu là cả hai cái.
Rồi thầy viết một cái câu giống như thầy đọc nhé, và con sẽ rephrase lại nhé. The voltage applied to each bulb, in the parallel circuit is greater than that in the series circuit. Okay. Con viết lại một câu gì đó nó tương tự như thế nhé. Bulb, bóng đèn. Tại sao mình lại viết cái từ both? Each both nghe đâu có nghĩa lý gì đâu hả? Còn trên này thực ra là higher current passing through each bulb. Higher current passing through each bulb. Okay, what is it greater than that? Okay, well done. Okay, tóm lại ngày hôm nay con học khá là tốt ha, mặc dù đôi khi mình hơi chậm một xíu thực hiện cái request của thầy, nhưng mà như vậy là cũng tiến bộ hơn so với trước đây. Well done con, bye con, tí nữa mình sẽ học tiếp môn khác ha, môn biology ha.